Hello everyone, welcome to lecture number 4 for Applied IoT. Hope everyone is doing well and has gone through our earlier earlier lectures, right? We will just quickly go through a preview of what we have gone through, refresh our memories, and we will start from the point we stopped last time. So uh, we are talking about applied IoT or Internet of Things. So first and foremost, we took an introduction to Internet of Things. Then we took an introduction to devices that are being used in Internet of Things. Of course, these are very limited number of examples here, just to refresh our memory to understand what is the Internet of what are Internet of Things, what devices are connected to the Internet of Things. And then we looked at examples and examples of applications of IoT devices. We looked at one linear application, from weather monitoring IoT device to the thermostat controlling the AC or the heating unit of a home, a building, in a shopping mall, a huge hotel tower, or let's say a business center or something, anything like that. We talked about the temperature control using IoT devices, a linear application. Then we looked at an example of multiple IoT devices working together to tackle one situation, which is a fire starting inside a building, right? How the smoke detectors for the control system, to the fire extinguishing sprinkler system, to the alert system to see if the people inside the building is healthy or not when the fire takes place, from alerting the fire department, so on and so forth. We took that example as well. From that example, we took a set or one unit of IoT device which is there to monitor the weather, can be used for different scenarios, different domains, or different industries or applications, based on the information that is being taken from those from the weather monitoring IoT device. We can make decisions on different again industries, domains, and fields. We can be more productive. Human error can be mitigated, so on and so forth. Then we looked at a mix and match of different IoT devices working in different environments or industries or domains, how we can apply them. Then we took introduction to applied IoT, and I will read through it again. Applied IoT refers to the practical application of Internet of Things or IoT technologies and solutions in real world scenarios across various industries and domains. It involves using IoT devices, connectivity, data analytics, and cloud platforms to solve specific challenges, improve processes, enhance decision making, and create value. So this definition is very important, especially the last part of that definition, the last sentence of that definition, or the last part, right? We apply IoT to solve specific challenges or to solve problems, improve the process, improve any process that is already there. Either it could be manual or semi-automated process, right? Or even automated process. By introducing more sensors and IoT devices, we can improve the process. enhance decision making, right, and create value. We revisited each example and we looked at how these criteria are met. We talked about examples on different domains and different industries, right? We talked about the power grid, agriculture, logistics. We just went through them. Retail, healthcare, custom electronics, so home, smart infrastructure, so for on and so forth, security and surveillance, those things. So we now have an understanding of what is applied IoT, why we apply IoT, and what is the outcome we are expecting from applying IoT, right? The outcome should be either to solve a specific challenge or problem, improve process, enhance decision making, and create value. At least one of those criteria should be met. That is one of the main things, because when we apply a IoT solution, it cannot be a burden, it cannot be an obstacle, it cannot be a dysfunctional application. It should improve on what is already there on that industry or in that domain, right? So that is the main part of applying IoT, right? Then when we looked at characteristics of IoT or characteristics of a IoT system. When we integrate IoT system, we looked at what are the main features or characteristics that will be there on that particular IoT system. Like these are the common characteristics that would be there: connectivity, sensing, perception, data analytics. So in applied IoT, we will be going through not the technical information, but the concept of IoT, so that we have an understanding of what are the characteristics that a IoT application would have. So if we are to talk to our customer, if the customer says, I want to expand the business, I want to add on a new part to this, I have a new problem, how to solve that, can your already existing IoT network handle this? These characteristics are there in IoT. We should know that these characteristics are there in IoT, so that we can give a direct answer that yes, we can. So connectivity, sensing, perception, then data analytics, automation, control, scalability is one of those characteristics that is needed to be highlighted. Security, real time, heterogeneity, and edge computing. So we talked about step by step everything, right? How edge computing, especially edge computing, heterogeneity, especially when heterogeneity comes in when talking about legacy systems or old IoT systems being connected to new IoT systems or adding on new IoT systems. Real-time connection, of course, it's for connectivity. Security, privacy, that comes basically with every IT communication and network. Edge computing is something that we talked about to, if there are 1,000 IoT devices connected to a network, edge computing will help to release the strain on the network itself and the main system or in the cloud, right? We talked about scalability is one of, again, as I told you, when they want to expand, can IoT expand with the business itself? The answer should always be yes for that, right? You should, when designing a system or applying a IoT solution, it should be always with these characteristics in mind. These 9 characteristics should be there, right, in any solution. Then then we learned about introduction to machine to machine. Machine to machine, of course, I will go through the definition again. Machine to machine, or M2M, refers to direct communication between two or more devices, typically without human interaction. Two or more devices, typically without human interaction. It involves the exchange of data, commands, or information between machines, enabling them to collaborate, interact, and perform tasks automatically. So this is the definition of for machine to machine, or M2M, right? M2M concept was there before IoT came into existence, but today the lines between M2M and IoT is blurred. Today we can, if you look at examples, if you look at the fire extinction example we talked about before, we can properly see machine to machine communication and action without any human interaction, right? Sending this sending this alert would be done without any human interaction. The human would see the alert and then only act upon it, right? So if you take the weather thermostat IoT in a smart home or a smart building, if you see the temperature control, the controlling will be done automatically without human interaction. So this is also a M2M. These machines will talk to each other. So again, if you look at today's IoT and machine to machine, it's a blurred line, but one way to define it is M2M was there especially in industries, industrial scale. Industrial automation would be the main point of machine to machine, because before IoT devices came into play, there were machines communicating to each other, trying to automatically do their work without human interaction. I think I have given some examples. Best one that comes to my mind right now is a printing press, fully automated printing press. It would be a mechanically driven printing press, that the machine itself would talk to each other to understand and print papers quickly. Manufacturing lines, sometimes human interaction is needed, but most of the time it could be automated. So things like that. But today, because of IoT applications been adding into the machinery, right? We have the ability to automate most of the work that machines do. And we talked about industrial applications, and we started by talking about the very best application we can think of: robotic arms working together in manufacturing. Here we have pumps working together, right? They will be IoT devices. When talking about pump would be an actuator in IoT device, right? And there will be pressure sensors inside these pipes to understand the pressure and whether the pumping should be high or low, to measure those things. And it can so when the data is inputted into the system by a human saying, okay, this much pressure should be there on these pipes, the motors will do pump accordingly automatically. Above here is a remote controlled it's a remote controlled mining device. So in this there's a bit of IoT, there's a bit of human interaction as well, right? uh, the human interaction between the machine is done remotely, right? And there are plenty of IoT devices or machine to machine talking going on here as well, right? This remote controls and right, if you take the remote controls or touch sensitive buttons or everything which is here, and when those are moved, it is being communicated between this automatic machine, right? Inside the machine itself, we talked about how much IoT devices should be there to navigate by itself, give the pictures back, networking, and we talked about, because there are heavy lifting of boulders and things like that, there should be lot of actuators working together, motors and things like that. Even to measure the amount of weight that is lifting, there will be sensors working together. So as you can see, when we try to give examples for machine to machine, it is hard to differentiate. It is hard to differentiate IoT and M2M today, right? If I were to give examples from not up to date connectivities, right? We talked about, I think we talked about, one of the things that we talked about is payment system, card payment systems. We have credit cards. I think we talked about credit cards. So that is something of a closed loop. But then again, think about it, today all credit cards, either with safety protocols, have their own intranet, but uses the internet for fully communication. So in that perspective, where everything is connected to the internet today, it's very hard to find examples of machine to machine. Then so we try to give industrial applications, industrial examples to we try to give industrial examples to justify the terminology of machine to machine. The last example we gave here is the Amazon logistical company, where they try to automate the delivery system of the packages to the right place inside the logistical hub, and that is also fully automated. These machines will be talking to each other while moving so that they won't crash. There are sensors, cameras, processing power inside the machine itself, and everything while doing this. This is also a good example of M2M. If you remember, last time we talked about old school machine to machine talking, especially in oil and gas exploration, oil and gas drilling, mining, steel manufacturing, GPS, and these are all applications of machine to machine. And machine to machine would make sense in the 80s and the 90s, but after 2000s, and when IoT became prominent, it becomes a blur. It is not a bad thing that machine to machine and IoT today doesn't have a divisive line, because we can use modified properties of IoT to make machine to machine communication much better. So we talked about smart grids as well. From top to bottom we talked about them, and again we stepped into some small problems with of whether IoT is this IoT or is this machine to machine, right? So M2M communication plays a crucial role in modern power grids by allowing intelligent monitoring and management of electricity generation, distribution and consumption. It enables real-time data exchange between smart meters, power plants, substations and control centers, optimizing energy usage and improving grids reliability. So yes, we talked about them. We talked about each and every, we talked about storage to use of electricity and how that data can be used, so on and so forth. And another point would be even in old control centers, we know that when there is a high demand of electricity or damage in electricity, or when either there is a high voltage taking place, the trips will go off. That would be also a point of machine to machine talking to each other. A primitive example, but again machines to machine talking to each other to ensure safety. Now we can start today with M2M on transportation and fleet management. Transportation and fleet management. M2M enables real-time tracking, monitoring and control of vehicle fleets. It facilitates applications like vehicle diagnostics, GPS tracking, remote maintenance and driver behavior analysis, leading to improved safety, efficiency and logistical planning. Yes, there are many topics in machine to machine. So number one, we talked about self-driving vehicles, right? Number two, if you are interested in these kinds of self-driving vehicles and the new technologies that is there, if you have seen videos of Benz S-Class or BMW, in the new series, any series of BMW or Benz or very luxury, right, like either the 7 series or things like that, they come with technology of face recognition and to see if the driver is becoming sleepy, and those things can be monitored. The vitals of the driver can be monitored, and that would act as a safety protocol as well, right? So today that application can be used in trucks, where long distance trucks, humans have to drive them for a long distance with when coming into logistical supplies. That means safety can be ensured. That is one application. Then again, GPS tracking for any kind of logistical and fleet management, either if it is going to be taxis, if it is going to be trains, if it is going to be trucks driving in goods around the country, if it is going to be something like Uber or Uber Eats, or if it's going to be planes to ships, we can use transponders, GPS tracking to have an idea where and at which location these vehicles are, so that if anything needs to be picked up along the way, or if a crash is about to happen, or we can work on it, right? That data will be there. Right, so again they can be routed through channels in the most efficient way. Things like that can be done. So if you take the safety of the ship itself, right? If you have seen news, especially follow international news, you will see how maritime importance of a ship is when coming into logistics, how the ship is being tracked and why it is important to be tracked, because illegal activities might take place, so on and so forth. School vans, school buses will be much safer if you have those options available. Then again, we have all heard of vehicle diagnostics. Of it, remote maintenance is also an option for these, anything that is connected to the grid or to the internet grid actually. So for vehicle diagnostics, things will be much easier, the time will be much less, no need to check everything by hand or by visualizing, going under the truck, checking everything, right? We just need to download the data, and the data would say what is wrong with the vehicle and which part of the vehicle needs attention, which is a much more efficient and a better way, and human error will be lost from that point of view. We talked about safety, efficiency, and logistical planning. Yes, because if we have a fleet of 1,000 trucks, right? If you know, okay, which truck is where at a given moment, if there are additional planning, or we have to do new planning, if we have new logistical pit stops or new places that we need to stop and load or unload logistical objects, we can quickly change the route of the path of the truck, looking at the GPS data. We can check those things as well. So the applications, again, the applications are plentiful when coming into transportation and fleet management. Again, fleet management, when we are talking about fleet management, in Sri Lanka, where have we seen fleet management? One of the main things is familiar for everybody is oil distribution, petrol, diesel, kerosene, these oil distribution. We are very familiar with fleet management when coming into those things. So in a country, there is in that way there's those. Then we always see containers. So that's a kind of also fleet management. But fleet management does not stop from there. Fleet management goes to aeroplanes, ships, and so on and so forth. We have to keep every logistical component. If you take a ship, there will be thousands of containers in the ship, and there should be a method of having the data, maintaining the data of which container belongs to which country or which port, or otherwise it would be a logistical nightmare. So those things are also can be handled through IoT devices, like having RFID tags, NFT tags, and things like that, right? So again, we can see machines talking to machines. Let's say a truck which is delivering clothing from a clothing manufacturing place to the let's say to the port, right? For a container truck is going. It can always communicate with the GPS satellite to show that we are on the correct path. We can give real-time information saying that, okay, we are here, we are delivering on time. So when coming into business, delivery on time is really important. Logistical or fleet management, one of the things that you may have used is Uber or PickMe to travel or to get food or something delivered to you. You can track it real time. If you order something online, you can track those logistics on time, on real time. So these are all part of machine to machine applications, or again IoT applications. Healthcare. If we come to healthcare, machine to machine technology is employed in remote or patient monitoring, where medical devices collect, transmit patient data to healthcare providers, doctors and nurses. It enables real-time health monitoring, emergency alerts, and enhance the quality of care, especially for patients with chronic conditions. Yes, I think this particular part was specifically covered when we are talking about two examples. One, the smart hospital bed, and we talked about the same in the when we are talking about applications of IoT in hospitals. We talked about monitoring the patient in real time, whether the heart conditions, whether the amount of saline or the blood which is given, whether the pressure of the patient, right, the fever, the temperature of the patient, the motions of the patient, is the patient in distress or not, the blood oxygen levels, so on and so forth. There are plenty of devices which have been already built to monitor a patient, especially with chronic conditions, right, who are in a bad state, and alerts can be generated to nurses and doctors, and real-time monitoring data can be shared with doctors and nurses using M2M, because these machines, right, the machine with the doctor would be a PC or the mobile phone, right, the machines with the patient could be a heart monitor, right, a pressure monitor, things like that. They will both be connected to a network, either the intranet of the hospital itself or the internet itself. When it is connected to internet and those information is passed through, it will become a IoT. But this is also an example, a very good example of M2M technology, where machine to machine is being used. Let's see if we, for example, now before human intervention, if the oxygen levels in the blood of a patient is going down, oxygen can be supplied. If more saline is needed, more saline could be given automatically. So the machine to machine talking and action taking is part of M2M, right? To minimize the human interaction, right, and to do things automatically, right, typically without human intervention, right. So if some kind of a medicine is given in with the saline, like in the drip form, the amount of drips or the amount of medicine that is needed can be increased or decreased depending on the health indicators with the scans that have been carried out. Now think of again Internet of Things and machines talking to machines, right, M2M, right. We talked about transportation and fleet management, we talked about healthcare. How can we put them together and use in an IoT application? If you think about it for a moment, what is it? Things that travel and healthcare, ambulances. The information that is being the information we take from GPS satellites, right? Information about the patient inside the ambulance. There will be health monitoring tools. There can be a GPS. So if there's an emergency patient coming along the way, the hospital could be ready because they know the information of the patient, they know the information of the how long will it take the ambulance to arrive, so that the hospital can be ready to receive that patient and treat the patient immediately, because the information will be shared between the computers or with the doctors that are using the computers in the hospital and the IoT or the machines that are there, from the machines that are there in the ambulance itself. So so you can see how Internet of Things, when everything is connected to everything, new solutions can be given. When we were talking about the smart grid, we talked about a similar situation where we can take the weather information from IoT devices or from machines in that. Those machines can talk to these machines, and by weather forecasting models can predict whether it's going to be cold or hot. Either way, if it is too cold, the heaters will go on. If it is too hot, the AC's air conditioning will go on. That means electricity production have to be high. So things like that. So communicating between each other, and you can see now machine to machine talking in today's world is also IoT applications. Before going into the next domain or next industry, as an example, let's take these three domains or industries. The smart grid, where it is the main point of distribution. The smart grid is about producing electricity and distribution of electricity. Transportation and fleet management, we talked about, from shipping to flights to for the lowest level of either Uber Eats, things like that, even that also, or a part of fleet management and transportation. Then there's the sectors of public transportation, your taxis, right, your Pick Me, Uber, those shared economies, and how IoT works in this. And we have the healthcare sector as well. So one of the other points that we need to consider is, right, when you are talking about IoT, Internet of Things, data which is being generated in one industry can be shared with other industries. For example, let's say for solar power generation plants, wind power generation, we need to monitor the characteristics of the weather, right? In that particular case, right, we have IoT devices monitoring the weather. If you have a hydropower plant, if we know when it will rain or is it about to rain, we can get ready for the hydropower plant to actively increase capacity, because the water levels will go up, so controlling the water levels and so on. So in controlling a smart grid, IoT devices to measure the weather is important. If we have the same data shared from this domain to the domain of transportation, would that be helpful? Yes, of course. Right? For example, if you have your shared economy when coming into shared like Lyft or Uber or Pick Me, your shared economy, when it rains, people use more transportation facilities like that, right? We know that if it rains, public transportation will get congested more, and we would need to increase the capacity. If we are to understand the future of weather, and we would would predict that there's going to be a thunderstorm, or there's going to be a hurricane, there's going to be heavy winds. Logistical transportation through sea or air freight, logistical planning can be adjusted so that ships and planes will not encounter that storm and safely go on the journey, so that the product will be safe. So when planning heavy logistics, when planning huge logistical plans, weather information is also important. Similarly, in the healthcare sector, when there's heavy rain, there's flooding. When there's a hurricane, there will be trees falling down, houses being damaged. While that is happening, right, people will also suffer. That means the healthcare sector, when a natural disaster happens, when a natural disaster starts to take place, IoT devices can actually detect it, right, and let hospital staff know or indicate hospitals that they need to increase their production or their capacity of handling patients, because during a thunderstorm or a flooding there will be more patients coming in. So that means if you have IoT data in a data set in one domain, it could be shared throughout domains, right? This is financially important because, right, any smart grid operator can share that data with the transport sector or any other industrial sector, and also can by sharing that data there will be profits made. From that profits, overall financial benefits for that smart grid operator would be higher, right? So one of the points that I wanted to tell you is, by knowing by knowing all the data, or by sharing the data in one sector or one domain with another domain or another industry, there will be financial benefits, and that is the whole reason Internet of Things is there on the first place, right? Quite recently I actually watched a video saying that when you go into transportation sector, if you have a transportation electrical transportation fleet of, let's say, trucks, especially trucks and buses, these heavy vehicles, right, the amount of power that is needed to charge them could be more than the amount of power needed for a small city. When you have like 50 to 100 trucks and we need to charge them, right, let's say container carrying trucks, and they are all electrical, right? So that information that is being generated in the transportation or fleet management domain can be shared with the smart grid, so that the capacity of the grid can be increased. Otherwise there will be a loss of power, right? So for things like that, to make it more efficient, to make it more economically feasible, right, to address the problem of large consumption of electricity by a electrified fleet of trucks, we can share that data with the smart grid and different. So you can see that IoT devices, right, what would be the IoT device that is being used here? We can say the truck itself, or the electric truck, or the charging point will be the IoT device, and those devices will share that data with the electricity grid, and they can coordinate to supply enough electricity to the city and the charging points as well. So going into the future, everybody is planning to electrify vehicles, and transportation and fleet management will definitely have to coordinate with smart grids to provide enough electricity for supporting each and every vehicle, right? That means IoT devices or machines of transportation sector talking to machines in the smart grid. So things like that are also there when applying Internet of Things. In the world of machines speaking to machines, right, or hardware devices speaking to other hardware devices and taking in decisions, right, it doesn't when that machine to machine speaking becomes a part of IoT, it doesn't matter which domain you are in, you can share the data which is commonly being used in different sectors. So let's go to the other example, right, we have is smart cities. Machine to machine communication is vital for building smart city infrastructures. It enables interconnected systems for traffic management, environmental monitoring, waste management, public safety and other urban services, leading to improved resource utilization and sustainability. So mainly when creating smart cities, the sustainability point is the most important one, because humans today have recognized that we cannot use products one time and just leave it, right? We cannot use fossil fuels and survive forever. So sustainable methods, productive methods, more efficient methods, management of resources is important if we are to have enough resources, materials and so on and so forth, right? A good environment for the next generation. So if in a smart city, how we can use machine to machine communication, right? Machine to machine communication with IoT in let's say in a smart city. Street lights. This is a common example, right? We talked about this before when we talked about examples, right? Weather monitoring machines talk into street lights, switching them on when light is low, right? This is very efficient. This stops wastage, and lights will be turned on whenever it is necessary, so the safety of the people who are in the road itself will be also guaranteed through that. Electricity consumption, yes, we can monitor the electricity consumption of a city, right? And we can even have past data to measure, okay, during this time, during the summer time, the ACs will come on, there will be more electricity consumed. During the winter, the heaters will come on, electricity will be consumed, but during in autumn or springtime, this will not happen, right? Energy consumption will get a little bit lower. That this data which is being collected in a smart city is can be shared to a smart grid to facilitate the electricity needs. Water consumption, this is also something, so water facilities is something that is being given as government law, city utilities, right? These are utility management. So water consumption and wastewater management is something that is done by either the city government or the central government or provincial governments. And if we have tools to manage the amount of water consumed, the amount of wastewater that is being produced, the amount of wastewater which is being produced in a rainy in the rainy season, so that if extra wastewater management steps have to be taken, that can be done. how to measure these things? Of course, IoT devices that have the ability to measure water pressure can be used in these pipelines to have a idea of where the most congested when either rain or consuming water, right? They can measure the pressure of the pipes which are going underground and have an idea about the health of those pipes. Are they working properly? Are there any blockages happening? Right, from the readings of the pressure itself, these things can be managed. Gas and energy consumption in Sri Lanka, mostly gas is distributed through cylinders, but we know that in Colombo there's a program to distribute by pipes. In most of the countries, similar to water and electricity, these are being distributed through pipes. So again, in gas and energy consumption, right, if you take gas itself, right, we can use pressure sensors to monitor the amount of gas which is being used, pressure of the pipes, and the health of those pipes depending on the pressure. Emergency response management. So emergency response management, fire brigade, ambulance services, police response. We talked about examples of how we can use IoT or machine speaking to machines to manage to manage these emergency response times faster. So when coming into emergency response, the response time is really important. The faster you engage with incident, the faster you can get in, you can control the incident and get a positive outcome of a tragic scenario. So that means if we have IoT devices, traffic cameras to see accidents, we have smoke detectors to see if there are fires taking place, and if those things can communicate to the local authorities, fire brigade or the ambulance services, as soon as they detect something has gone wrong, they a quick response can be done, thus saving lives. Public transportation, parking meters, right? Public transportation itself part of transportation and logistics. We there in Sri Lanka, if you remember, there was the idea of introducing a smart card to public transportation buses, where you can do your payment through a smart card. So things like that are available in other countries. If you take a metro station or metro services is something that is a place where machine to machine interaction is heavy, because metros work with electricity. There will be a rail, a separate rail running parallel to the metro line, which would carry electricity. So there would be grid management, there would be sensors detecting in where the exact location of the train, right, the metro train, where it is positioned, where's the next train in front of it, where's the next train behind it. So sometimes there will be metro trains coming in every 10 minutes, 5 minutes. To manage these things, there should be machines, each train talking to each train, right? If there is some kind of a disruption, the whole system have to stop, and those things have to be communicated quickly. So that means that every machine should be able to talk to every machine. They have to have the ability to see how many people are getting into the metro, are they all in, so they can close the doors, and the closing of doors are automated, things like that. So that means IoT devices plus all those IoT devices are speaking to each other to have a smooth continual process going on when coming into things like metro and public transportation. Parking meters, of course, smart parking meters can be used to bill anybody or to check whether there are parking violation. Waste management, recycling, waste collection, storage and processing, that is it in itself is a separate topic. uh, in Sri Lanka there was attempts, and there are still attempts, and there are successful attempts in recycling and waste collection management, but there's a lot to be improved, right? And these systems also can be automated. If you see waste management sites abroad, there are systems that are there to detect metal, to detect plastics, and detect and separate them automatically. All those machines work with sensors, and those machines work by themselves, the fully automated systems. That means each sensor is talking to each actuator to separate the recycling and the waste. So it's a machine to machine communication there itself. Taxation, security, record keeping, so residency, democratic processors, and data storage, so processors for record keeping, part of IoT, part of cloud. We can see, like, for example, if you have a smart ID, and if you want to pay your electricity bills, or you want to go to your local police station and get some information or to seek help, you can use your smart ID, and the authorities can use your smart ID to cross verify with the database whether you are a resident of that region, and then they can help you in what you need. So things like that, documentation, even in taxation and those things, all come under documentation. They can be automated. They can be automated through smart ID. Food safety is a part of also governance, right? That would also be a part of logistics as well. So logistic management is a part of a smart city. But not only food safety, waste management is a waste management, and is also a part of logistical. Uh, uh, it is a kind of a logistical nightmare for any city, and would need a vast logistical vast logistical capabilities to handle, especially in a city where millions of people are living. So IoT devices can be used to support all of these infrastructure. Other topics include disaster management, financial services, public services. Disaster management, we talked about how we can use our weather monitoring IoT tools to predict the weather, and we can get prepared. Financial services, public services, schools, hospitals, banks. We talked about the hospital services. When coming into school, we have talked about smart schools. There were some plans to implement smart devices in schools. um, the success rate of it is very less in Sri Lanka, but in some other countries they have successfully implemented these features there. So a simple feature would be, every day when you go, your register will be marked on a school. Rather than marking the register, if the student has a school ID and it's a smart school ID, the student can mark their presence. Let's say it's a RFID device, right? So can just keep it on the scanner, and automatically the presence would be marked. Things like that, right? So for a smart city itself, we are talking about millions of machines working, talking to each other, right? It could be computers, it could be cloud computing, it would be data storage, it would be literal machinery such as waste collection, garbage trucks, and so on and so forth. Traffic lights to measuring of the amount of water that is being consumed, the wastewater, the pressure inside those pipes, and so on and so forth. So in a smart city, we are talking about, if we are to real time monitor and respond quickly, we are talking about millions and millions of IoT devices sharing data between each other even to make proper decisions, right? So the applications, the example of applications in machine to machine, right? So direct communication between machine to machine in industrial level or in different domains, right, is endless, right? I As we have a limited amount of time, I have given these examples, and I hope that these you when I say, okay, if we are going to measure water consumption, right, what would be the machine that we will be using to measure the water consumption? What would be the machines that would be talking to each other to have water consumption, right? I hope that you will be able to imagine what are the things, right? For a moment, there will be pressure sensors. If water is consumed a lot, the pressure inside the pipes will go down. Then the distribution location of water would know that more water is needed, right? So that data will be communicated to the pipes, right, and the pumps, and the pumps will activate to pressurize the water. So things like that. So you can see machine talking to machine, right? The topics are endless, right? But we have to understand, like for example, in the morning, everybody's going to office, everybody's going to have a shower. That means there will be more wastewater, there will be more consumption of water, and there will be more wastewater. On top of that, if it is raining in the morning, there will be a lot of wastewater. Then again, any pumps that are being used to pump out wastewater from the city have to be activated to address that, right? So again, machines talking to machines. Everything, the data will be processed, and from that processed data, either humans will be making decisions or pre-written code will be helping to take or to send that command to take the decision, right? So each and every, even if you take street lights, there can be a smart street light system would have cameras and sensors to detect how much traffic is there in one side and give priority to that particular side where there is more traffic, right? Things like that. Security, of course, we talked about when talking about IoT systems, smart cameras, motion detectors, so on and so forth. Right, food safety, if you take management of warehouses, we can talk about that point, right? There will be a lot of security cameras, resources, temperature control systems which will be needed for will be severely needed to, especially to ensure food safety without going bad. So the amount of examples are endless. The amount of use of machines talking to machines or the use of IoT is endless. So I hope now you have a general idea of in the world of machine to machine talking, how that would happen and how IoT becomes a part of it. So as I told you before, machine to machine and Internet of Things. So machine to machine concept came before Internet of Things, right? But nowadays the line between machine to machine communication and Internet of Things have been blurred. The development of technology, cloud computing, and so on and so forth has blurred the line between machines in a factory talking to each other and working together, and the same machines today using other sensor data and collecting data, sending it through networking into the internet or the cloud, right, and processing that data, having that data processed into information, and those information coming back as commands to function together, would be machine to machine plus IoT, right? So we will try to see the differences, or we will try to see the differences, or what is machine to machine and what is Internet of Things, and try to understand the difference between those two now. And again, because machine to machine is a old concept, right, the new concept when going forward, or where it will be IoT, right, wherever there is a IoT application, there is definitely going to be a machine to machine application. So trying to understand the differences, let's start with the scope of these two. M2M communication focuses on the direct exchange of data between machines or devices without human intervention. It typically involves a limited number of devices within a specific application or industry. On the other hand, IoT expands the scope by connecting a vast number of devices, not limited to machines, to the internet, enabling them to communicate with each other and access cloud-based services. So as you can see from here in itself, right, the scope of M2M is very limited. The number of devices that are connected are very limited. For example, and it is something that was created, this machine to machine or M2M is a concept of automation before IoT. If you take steel manufacturing plants or other kinds of different manufacturing plants, you will see that the production line, the manufacturing line is mostly automated. If you have like drinks or water bottling plant, or packaging plant, or construction of vehicles, if you take, rather than the modern day, the old days, right, most of the automation was happening machine to machine. When one machine finishes a particular set of work, it informs the other machine, then it's your turn, carry out your work. The sensors in those machines will be exchanging data between each other. There were custom made protocols or custom made software just for the communication of the machine. Think of a printing press, printing of papers, which is not something famous these days, but before the time of the internet, automation of printing presses was a very important thing, because the efficiency and the high number of printing that can be carried out in a day is very important to distribute information very quickly. So in machine to machine, you can see that these are legacy systems that are talking to each other. But if you take examples today, right, if you go back to the industries, right, if you take a system, a pumping station like this, it could be oil, it could be gas, it could be water, wastewater management, can be anything. A pumping station could be used, or in a electricity power plant, nuclear power plant, a pumping station is used, so on and so forth. These machines have the ability to talk to each other, and maintain the pressure without the intervention of humans. And that is something which was there before IoT, before Internet of Things. They don't need to connect to the internet separately to function. But if you take IoT, right, think of they are pumping this water 100 kilometers away, right? This plant would pump water 100 kilometers away. In an M2M system, to see if the pressure at the other end 100 kilometers away is correct, there will be internal communication systems with the sensor providing data directly to the pumping station or the pumping machines, right, to the motors. But if you have a application of Internet of Things, this data could be securely passed through an existing network, which is the internet, to the pumping station. No infrastructure needed to be built expanding 100 kilometers, a wire expanding 100 kilometers just to get that data, right? So the difference between M to M would be, if we need to measure the pressure at the end of this pipe, maybe 100 kilometers away, that sensor data directly coming through a wire or some network, internal network system to these machines could be categorized as M2M. But if that particular data is coming through the internet and not using a internal resource, right, that would be IoT. So having an IoT method to communicate using the existing infrastructure of the internet itself to communicate is much more efficient, and it is economically friendly rather than having to maintain a separate communication channel or a wire for 100 kilometers, which is a hard thing to do, right? If you take a manufacturing plant, right, these robots have their own software, they have their own commands, they have their own sensors. There will be a data center inside this manufacturing plant controlling this data, these arms, right? Each arm will perform their task and send the data back to the data center, and then the data center will process that data and give the commands to the next arm to carry out its work. So it will be a synchronized working environment where codes will be dominating the actions. In a sense, if this machine wants to communicate with this machine, it can be done because of the internal networking that is there, right? This machine does not need to go to a cloud-based scenario or to the internet itself and share the data with the machine next to it. It can use internal communication or networking between each other, plus maybe a network intranet system which is running inside the factory with a data center inside the factory to process the data. That would be again machine to machine communication. If this data needs to be analyzed by software developers who are not in the manufacturing facility but in a separate building in another location, another town, another country, or a third party application provider, another company, they need to analyze the logs, they need to make the system better, they need to understand what went wrong or things like that or they need to carry out updates for that particular part, or if these machines needed to be controlled remotely, or real-time data should be provided to the headquarters. For example, this manufacturing plant could be in let's say this manufacturing plant is in China, but the data of this manufacturing plants should go to the automotive industry, let's say the headquarters, which is based in Germany. That means that in real time they should send the data of these machines working, the health of these machines, and so on and so forth. So for all those reasons, they are connected to the internet. That's when IoT comes into play, right? So now we can understand the scope. M2M communication focuses on direct exchange of data between machines. Of course, this happens if we are to build an embedded IoT system, right? If we are to build an embedded IoT system, it would be machine-to-machine communication. Take this Roomba for example. The sensors, those devices will be talking to the actuators, which are the motors inside this, to navigate. They will be not connecting to the internet and taking information. Of course, when the cleaning is completed, it will send an alert to the owner of the house from a app or the phone using the internet. But to function, it will be communicating internally. So it would be machine-to-machine communication. But today, when we have everything connected to the internet itself, the convenience and the ability to access cloud computing, of sharing resources, because we have the capability today, again the machine to machine factor is almost non-existent anymore, right? But I think you now understand the scope of machine to machine. This is in your syllabus, so that's why I'm trying to explain what is machine to machine and how IoT and machine to machine get together, or is a set in today's technology, a single set. So if you take connectivity, M2M communication primarily released on point to point connections, right? That means if you take again the embedded system, right? If you take an embedded device, IoT device, it would be one device. The sensor will be communicating directly to the actuator, or the sensor directly to the processing unit, the processing unit directly connecting to the actuator. Often use specific protocols and technologies. It typically involves wired or wireless connections between devices within a localized network, so a intranet. IoT, on the other hand, leverages the internet as a communication medium. Right? IoT, on the other hand, leverages the internet as a communication medium. We talked about the pumping station. We talked about the example of the pumping station, where if you want to communicate 100 kilometers, M2M will be using its own wires, which is expanding 100 kilometers, which is a problem of its own. But IoT will be utilizing the internet. IoT devices connect to the internet and can communicate globally, leveraging a wide range of networking technologies such as Wi-Fi, cellular networks, low power wide area networking, right? So again, the main point of IoT is to leverage the internet. Machine to machine communication was there for a long time, but by leveraging the internet itself and the resources of the internet with today's cloud computing, machines can be more efficient and can function in more real time, right? So the connectivity, you can see the exact difference. We are talking about localized, that means an intranet, right? The difference is basically a intranet versus the internet. Why IoT devices are more important? If you take industries, if you take companies like, let's say, BMW, Volkswagen, Benz, or if you take other huge industrial companies which are out there for manufacturing, right? Their manufacturing is located globally. So they need to keep an eye on their inventory, and they need to keep eye on their plants in real time. So they are not able to have a they are not able to have a network built for their own, but they can build their own intranet or their own networking architecture, leveraging the leveraging the protocols of internet itself, right? As we talked about the examples, right? Today the manufacturing plant could be somewhere in, let's say, okay, the manufacturing plant is located in South Africa. The company is located in Canada, right? So if the headquarters is in Canada and they want to check real time what is happening inside either the manufacturing plant, the pumping station, or the distribution station, or mining, or whatever, one is in South Africa, one is in Canada, we can leverage the internet and use the cloud computing components to relay that data to them, right? So this is the connectivity difference. Data sharing. In M2M communication, devices typically exchange data with each other in a closed network environment, often for specific purposes or applications. It could be a specific reason, a specific application. The data exchange is usually limited to the device involved in the communication. In contrast, IoT devices are designed to share data beyond their immediate environment. So that this is something that should be highlighted. So if you are building so M2M devices talk to each other but does not share anything, that particular set of data, with others. They can so we will finish this part. They can send data to cloud platforms where it can be arranged, analyzed, and made available for various applications and services. What is the best example? When we talked about these different domains, we talked about how these different domains share the same set of IoT data, which was weather data. With the example we took was weather data, right? So if it was a M2M communication only, that data cannot be shared between different domains, and each domain should have its own weather controlling or weather monitoring system, which is not efficient, which is not practical, right? It is costly and it is hard to maintain, right? We talked about the advantages of it. Now you can see what is the main difference between M2M and IoT. In the world of IoT, when you look at the scope, the connectivity, and data sharing, the clear advantage today is to use IoT solutions rather than legacy M2M solutions. Scalability. M2M systems are generally more focused and specialized, involving in limited number of devices within a specific context. They are often developed for specific industrial applications or verticals. So for example, again, manufacturing plants with specific needs, right? If you are having a manufacturing plant to manufacture steel, if you're having a manufacturing plant to manufacture, let's say, chemicals like fertilizer, which are more very highly volatile substances are created, right? There will be custom made machines. These custom made machines will be talking to other custom made machines to handle those manufacturing needs, right? So in that case, M2M is necessary, but in the world of IoT, these machines could be directly connected to the internet itself and be controlled. IoT, on the other hand, emphasizes scalability. It enables the connection of billions of devices across various industries and applications, ranging from custom electronics to industrial machinery, healthcare devices, and smart cities and infrastructure. So again, the scalability point comes into mind. If you have a custom built machine or set of machines talking to each other, and they are using protocols and methods to communicate between each other, which are custom made, nobody will or anybody who nobody will have the ability to integrate new systems into the manufacturing line without knowing what was the custom built application, what were the custom built protocols which are there on the system, right? So that's why when coming into scalability, if you want to have one manufacturing plant and you want to replicate that in another place, and you want to do it with minimum amount of financial investment, rather than having custom made systems, protocols and networking, we can use IoT systems which are commonly used. The protocols are commonly used, the internet is leveraged, right? Cloud computing is leveraged, and that manufacturing plant could be replicated in another place. Then we have data analytics. While both M2M and IoT involves the exchange of data between devices, IoT places a greater emphasis on the data analytics and leveraging the insights derived from the collected data. With the widespread connectivity and the cloud integration in IoT, data can be stored, processed, and analyzed on a large scale. This allows for more advanced analytics techniques, including big data analytics, machine learning, and artificial intelligence, to derive value insights and to derive valuable insights and enable data-driven decision making. So now we can understand that in the modern day, right, just automating does not mean communicating between machine to machine. So in IoT, that's why it is excelled machine to so IoT have a vast array of advantages, including the use of cloud technology and big data. So we can process that particular set of data, and we can either make new decisions or improve the process of, let's say, for example, in manufacturing, right? So for those things, that is why IoT is a much superior solution which goes beyond M2M. And in the world where we are leading to automation in manufacturing, basically everything in manufacturing is now driven towards automation. M2M is not the option, but IoT is the present and the future when coming into automation in manufacturing or machinery sector. Ecosystem. M2M is often associated with specific industry verticals. The communication protocols and technologies used may vary based on the application. So again, because these are custom made, right, sometimes it would only integrate into one particular industry, the sensors would only work in one particular set of software, one particular set of machines, and using one set of protocols. The machines, the integration between machines is not possible from industry to industry. IoT, on the other hand, represents the broader ecosystem that encompasses various industries, devices, platforms, and standards. IoT ecosystems involve a wide range of stakeholders, including device manufacturers, service providers, software developers, and data analytic companies, all working together to create innovative applications and solutions. So you can see that because the larger ecosystem is working with a set of protocols. If you learn about building an IoT device, right, there will be a set of protocols that are internationally recognized and that are being used, so that all IoT devices can be integrated into the internet itself. Thus, data sharing is possible, right? So rather than having machines to rather than having individual custom made machines which would fulfill the requirement of the, let's say, the manufacturing factory, or let's say a large mine would have the ability to automate some mining process, or a ship manufacturing company, a shipyard would have the ability to streamline their process and automate their process on ship manufacturing. That particular set of industrial machines cannot be integrated into other industries. Let's say a welding tool used in a ship manufacturing yard, which is made in a M2M process, will not be able to get integrated into a building manufacturing or another a car manufacturing plant. But in IoT, it is made in such a way that the ecosystem supports the shared ecosystem supports a standard, so that a welding machine, a heavy welding machine in construction business could be same used in a ship manufacturing place, and also can be used for manufacturing vehicles, so on and so forth. So now you can see that if you take M2M, right, it is a legacy methodology, and that IoT is the future. So why are we, so it was in your syllabus, and if you think about it, we are going to learn about the application, or we are going to learn applied IoT. When talking about applied IoT, right, if you go back to the definition itself, right, we have solve specific challenges, improve process, enhance decision making, and create value. So these are the points that we need to address when applying a IoT solution. Now in legacy systems, if you have a M2M system, applying an IoT solution to improve the process, making that M2M connectivity into a IoT would be the next step, the next natural step to be made, which would create value and which would improve the process itself, right? How IoT devices or IoT sensors could be integrated into a existing heavy machinery, how that data would be shared, and how that data could be processed and stored, and these things, right, in the world of the internet, cloud computing, big data, so on and so forth, where IT is everything, M2M, the concept of M2M is now turning into IoT. And when learning to automate manufacturing lines and huge industrial applications, knowing what is M2M and what can be the IoT solution is important. As you can see the differences, right? Now you will be able to understand what is M2M and why IoT is a better solution than M2M. Because we talked about M2M, right? I wanted to talk about another topic which is similar to M2M but which is not in your syllabus, but I thought it was important. Operational technology. So for example, IT, information technology, we all know, we all learn about it, and in use of IT there is another part called OT, or operational technology. Operational technology is hardware and software that detects or causes a change through the direct monitoring and or control of industrial equipment, assets, process and events. The term has become established to demonstrate the technological and functional differences between traditional information technology systems and industrial control system environments, and so-called IT in the non-carpeted areas. So for example, what is OT is that if you have, so for example, if you have a business app, we have business applications, we have HR applications, ERP applications to handle inventory, we have applications to do payments, we have applications to store data, to collect data, to carry out our businesses. We have different products, right? And even in Sri Lanka there are applications that were made. We have ticketing, booking, right? We have end user, we have account management, end user management, we have a networking, we have data centers, we have cloud computing, we have then we have the security sector separately, backup, database management, application management, so on and so forth, all in the IT sector to support businesses, especially services. But in the business environment there are two sectors, right? In machine to machine, when we are talking about machine to machine, we understand the manufacturing does not only, or the business does not only have software components to it or IT components to it. There are hardware components that are working with code, that are working with a IT infrastructure in hand, a networking infrastructure, where its sensors collects data, where codes are or applications are running and commands are given. A large amount of data is collected, real-time data is collected, remote controlling, remote accessing, those things are also being done. What that means is there are industries around the world that not only rely on IT but hardware components similar to IoT, right? So same as MOM, OT or operational technology is one of those parts that we can also come across. So because of that is why I wanted to just brush upon operational technology also, because we are talking about M2M. Same thing when you automate these things fully and when you have your own control centers, monitoring tools and so on and so forth, right? When you apply IoT to the manufacturing process, when you apply IoT to your hardware devices, your physical devices, That means you are applying a hardware software that detects causes changes through direct monitoring and control. So it is the same thing as M2M. It is the same thing as IoT, but operational technology like IT, OT is a term, like M2M, OT is a term that is being used. Whatever the situation, it is clear that all these either OT or M2M, right? The application, the end application would be a IoT application in current day, right? Now we have a general understanding, right, of applied Internet of Things, right? We took an introduction to IoT. We then looked at examples of IoT devices. We looked at how IoT applications take place, a single application, then multiple IoT devices for a single application, then a single IoT application for multiple domains or industries or occasions, then different devices in different applications. We talked about them. Then we stepped into the introduction of applied IoT, right? And in that, the definition goes as applied IoT refers to the practical application of Internet of Things technologies and solutions in real world scenarios across various industries and domains. It involves using IoT devices, connectivity, data analytics, and cloud platforms to solve specific challenges, improve processes, enhance decision making, and create value. Solve specific challenges, improve processes, enhance decision making, and creating value. So that is the part that is needed to be highlighted. If you are to apply a IoT solution, a IoT system, it should either solve a specific challenge or a problem, improve the existing process, which could be a M2M system, which could be a OT system, right? It could be anything, but end of the day it is IoT, right? Enhanced decision making, that means the amount of data being collected will be increased. Thus a good decision making can take place. We talked about the best example we can take, which is the weather. Then create value, how these things improve and create value to the business itself. End of the day, when you have IoT application to your home, to the infrastructure of a city, end of the day, it should create value. It could be from financial sense mainly, right? It could come from efficiency or the new business opportunities it creates or the savings it does. So creating value comes in that, right? Then we talked about characteristics of IoT as when you apply a system, right? The connectivity, sensing, perception, data analytics, automation, scalability, and so on and so forth. Then we talked about M2M, right? And today how M2M has turned into IoT itself, right? And we talked about multiple number of scenarios where M2M is applied, or IoT, in today's terms IoT is applied, right? Then we looked at the difference of machine to machine and Internet of Things. And here we understand from the scope, data sharing, connectivity, and scalability, data analytics and ecosystems. We understood that M2M is a legacy terminology, a legacy theory, which is now mostly can be covered by IoT. Then we also had a sneak peek on operational technology, right? We mainly did that because that is also a term that is coming up, right? M2M is a legacy term. After M2M, it was IoT. Now OT, operational technology, is also a term which is used in this sector. End of the day, all these terms and everything would be IoT, and we should know how to apply IoT solutions for existing M2M systems or building a new system from ground up. Whatever the situation, we have to identify the problem, the challenge, and we should apply a solution or understand the process and apply a IoT solution to improve the process while creating value. So as we have a understanding of IoT application or applied IoT, right, we could understand that the vast nature of usage of IoT in different sectors, right? We talked about how Tesla has its own IoT. If each vehicle is an IoT device in itself, how Tesla would have its own IoT ecosystem, right? We talked about these examples. We talked about power grids, agriculture, right, logistic, and so on and so forth, right? How M2M and IoT works on those levels as well. So right, for today we can end it from this particular point, and in the next lecture we will be going into the market perception of IoT, right? We will be looking at how the market is shaping up, how the market will be into the future. Is IoT relevant, right? Right now we can see from the technology which is out there, M2M is irrelevant, right? It's becoming irrelevant very quickly when each M2M solution is being replaced by IoT solution, right? And there is similar to IT, there's a separate field growing called OT, operational technology, just for this kind of scenarios where machinery and hardware components are being monitored and so on. It, of course, if IoT OT is the same, right? There's not much of a difference when you take technology wise what is what. So from next lesson onward, we will be looking at the market perception, what will change the market, what are the risks in the market, and how IoT will shape the future and how things will go through, right? We will try to look at it in an up-to-date manner, right? And we will move forward from that point of view, right? After understanding the market itself, applying IoT solutions would be much more easier, or much more would have an understanding of what sectors are looking for IoT and how IoT would help each and every sector, right? We talked about applied IoT, and value creation is a key part of it, right? If value creation is a key part of it, then we should understand that, right, there should be a market perception to it, right? We will continue that part in the next lecture. So for now we will stop it from this point. So thank you everyone, hope you have a great day. See you in the next lecture.